So with that, I'm going to transition also into our final panel session, our final set of presentations. And it really picks up and builds on the theme that Jennifer introduced to us, which is how do we start to build research and development networks and consortiums? How do we start to make this more than just a few companies with a customer focus or looking at circularity or sustainability, and how do we kind of move towards a bigger picture and towards a movement? And we think this is a combination of academia, of companies, technology providers, as well as thinking about policy and things like that. So with that, I'm happy to introduce our first speaker. On the program, unfortunately, it's not Fikret Calais from Autodesk. He was not able to join us due to illness, but we're really happy that we have another representative from Autodesk Research, so I'm really happy to introduce Fope Bademosi from Autodesk Research. Welcome.
Hello. Okay, good afternoon, everybody. Thank you. My name is Fope Bademosi, and like he said, Fikret could not be here today, so it's my pleasure to be here representing him today. And today I will share Autodesk's perspective on the industrialization of construction, but from a research point of view. And when we think about the industrialization of construction at Autodesk Research, just, in accordance with everything we've heard today, we believe that the future of the built environment is industrialized. Some of the major challenges that we've seen from our customers that are driving this shift towards industrialized construction include things like the unmet demand for housing or buildings in general. As a lot of you know, the global population is expected to reach 9.7 billion by 2050, and we simply do not have the housing, the buildings, and the infrastructure needed to accommodate the growing population. So we've estimated that the world needs to build 96,000 new affordable homes every day to house the projected 3 billion people by 2030. Another challenge that we've seen driving this shift is poor sustainability. Not to dwell too much, but we know that the construction industry accounts for 35% of landfill waste, and buildings also account for roughly 40% of CO2 emissions. So there is increasing pressure to make construction more actionable and also to achieve meaningful improvements. And the last challenge that we've seen are significant issues associated with attracting and retaining talent in the workforce. Over 2/3 of working architects are within 10 years of retirement, with many planning to leave the workforce within the next 5 years. And currently we have over 25% of construction workers over the age of 55. And with this trend that we're seeing with retirements continuing to deplete the workforce, we've seen a lot of loss in valuable knowledge that could help the industry. So at Autodesk, we are considering all of this seriously, and we are deeply committed to our mission of developing and delivering new connected solutions designed to transform the built environment through industrialized construction. So our goal is to enhance certainty, boost productivity, and empower our customers to meet their sustainability objectives. So what's currently happening in the landscape of industry practice? We've seen a significant gap between the AEC and manufacturing industries, some of that which have been highlighted here today. And this is characterized by the disconnect in our workflows and the tool sets that we have in both sectors. And historically, Autodesk has attempted to build this gap by providing some interoperability among these tools, but complete integration is yet to be achieved. We've also seen companies starting to adopt industrialized construction to overcome these challenges, but we've, from what we've seen also, the modular construction industry has faced significant failures, and some of the more resilient companies are still standing today. We see that some of them are struggling to make profit. So achieving scale is challenging, and architects aren't really adopting the design for industrialized construction principles. So we think that architects need to be equipped with the tool sets for industrialized construction in order to move the scale, to move IC on a broader scale. With this, there is a need for a shift in our approach to the way we design buildings, right? So typically, if you look at the curve, the ability to influence design, building design cost is high during the early stages of design, so program definition, conceptualization, and choices made during this stage typically make or break the project down the line. The challenge with traditional building methods is that certainty is very low during design because every project is a blank slate and you're starting from scratch. Designers would typically capture design intent with placeholder content at the very beginning, and all the other details are authored much later down the pipeline, which would be complex or costly to change directions at that point. However, with using industrialized construction, we can start projects with chosen suppliers and known manufacturable components and building elements. Right? So this is what we're calling productization. And productization allows architects to use components and make choices that are validated early on during the design process. And this has a downstream impact of eliminating manual time-consuming processes, decision-making, and so on, because these tasks are performed with the components or the products in mind. So to just share our current landscape at Autodesk, how do we enable our customers to design with productization in mind? We have the Autodesk Informed Design Platform, which seamlessly connects the dots from product engineering to design customization, and finally to production outputs. So the workflow essentially starts with the product engineer at the publish phase, where they create parametric models, set BIM contents and rules, and then publish the product for design use. And then it's transferred to the designer during the customize phase, where they adapt the product to project requirements, integrating them into the entire project and prepare them for production. And then in the last phase, the project engineer finalizes project selection and generates the necessary information, so your fabrication models or documentation, your bill of materials, shop drawings, and so on. And all of this is integrated in the Autodesk Construction Cloud. So the Autodesk Informed Design is available as a plugin for Revit and Inventor. That was actually just launched today, so please check it out and let us know. But this workflow is definitely inspired from industrial practices like standardized design and assembly and efficient supply chain coordination, as seen in shipbuilding or automotive industry. However, it's essential to note that industrialized construction does not equal manufacturing. So it's not the same. Unlike ships or cars, buildings are rarely identical, and they often need to be tailored to the unique requirements of the site or the owners, the end users, and all of that. So while we apply the principles of shipbuilding, precision, and automotive efficiency, we must adapt them to the world of the versatile construction industry. Which leads me to the plans that we have for the future at Autodesk Research. We plan to transition from discrete products to a more seamless industrialized construction workflow experience, sharing granular information, data between all our industry clouds, so Forma and Fusion, supported by the Autodesk platform services. So this is where our research starts at Autodesk. Our research aims to de-risk a future that industrializes high-mix building products, both in complexity and variation for use in new construction as well as existing buildings, retrofitting existing buildings. We are abiding by 4 basic principles, which we think is necessary to think about in the industrialization of construction. First being that industrialized construction doesn't start on the construction site, but with how the buildings are designed. So this is one of the main areas we are currently tackling. Also, industrialized construction is not only about building housing in a factory. There's a spectrum of ways that construction is automated that extends from the factory to the construction site. And then in order to move from a factory setting to a construction site, we know that there's a lot of dynamics associated with an unknown environment, so things like the land, existing surrounding buildings, and so on. So we know that it's important to digitize all of that, digitize the IC environment before we can move to the site. And our last principle is human at the center of it. So we know automation is not all about the machines. It's about the people that we are engaging at the automation process. So currently, our first activated project, Designed for Industrialized Construction, DFIC, Designed for IC, tackles these 2 main research principles or areas. As mentioned already, the AC industry operates on a disconnected project-based operation model, and at a different scale, our software is also disconnected. For instance, the complexity required to pass information from Revit and to Fusion. So one of the things we're trying to do is close the loop using Autodesk data exchange from design to production through manufacturing services. And here is a more, detailed diagram of our workflow, starting first with the design stage, where we have a design with a low level of development, so LOD 200 to 300, and then look into the component specifications and requirements to generate fabrication geometry on individual building systems. And then we have the manufacturing phase where, so I really can't see with the blue, but we're focusing on passing the information from design to manufacturing services, where we then generate, all the manufacturing data and have all of that ready for production. So things like your setup sheets, your robot path planning, and all of that. And then the beauty of this workflow is once we're done with the design and the manufacturing product services, we have all that information kept in a digital twin. So from that digital twin, we move on to the physical space, which is the production stage, and we can predict production workflow graphs and supervise the process and everything, including the assembly of the product in a factory setting. So I'll walk you through the workflow in more detail, but using this workflow, we tested it with a prototype in the Boston Technology Center, which is a simple wooden floor cassette featuring an HVAC system. And this is not your typical conventional, what you would do typically in practice rather, but it was just a little research to test our methods. So diving in first with the design piece. As we all know, and there's a diversity of applications and components in industrialized construction, which leads us to a diversity of materials or combination of materials that require several manufacturing technologies. So the idea of the design service is to move from a low LOD, so a low level of development design, to a high complex component that requires deep knowledge of the material, the manufacturing and production capabilities, and the assembly, all at the design stage. So the intent is to help designers move from low LOD design to a multi-scale design optimization. So to enable designers, we are embedding manufacturing constraints very early on in the design. And moving from design to the manufacturing environment, we are using the Fusion API to separate the assembly, so separate the bigger assembly into individual parts, and then use metadata to identify the machine features, and then also specific features in the individual components that would require manufacturing attention, then calculate the tool path, generate the NC code, and package it with the machine data, and provide it to the production services for manufacturing, right? So this just like takes the design, pieces it into individual components, and identifies features, calculate the tool paths, and you can package that NC code and machine data for production. So the final step is to move from the digital environment, design and manufacturing, to the physical one, which is our production. At this stage, we have all the list of components and all the elements that need to be fabricated. So we developed a tool that analyzes all design and manufacturing data to produce multiple production scenarios, as we can see. The tool considers things like the availability of machines, the capacity, optimization, cost, and so on. And the tool also creates a workflow graph, as we can see in the video, that represents the production flow of a factory and can also monitor the activities in the factory and identify any gaps. We're actually able to, some of our team members in France, were able to remotely monitor the initial prototype produced in Boston. So our goal is to enhance production prediction and collaboration. So in a nutshell, that's the workflow. You have your design services, your manufacturing services, and your production and assembly services. The diversity of applications in industrialized construction doesn't allow for a single solution or workflow to respond to all the vast applications, the vast materials and all of that. But we believe that we can leverage the platform services or solutions that we have at Autodesk and cloud computing technology to provide generalizable services for our customers to build their own workflows. So this is where we're starting our research on industrialized on industrialization of construction to be able to provide architects with the tool set to design for industrialized construction. Please stay in touch with us on social, and that's my email and Fikret's email as well. And we look forward to questions and hopefully collaborations. Thank you.